And today we are going to do a question about chi-square. They crossed black body eyeless with wild type. And I told you what wild type means. It means the most common phenotype or the normal phenotype, what we expect to be existing in the population. And when they crossed them, all the offsprings were wild type. What does it mean? It means that these wild type genes, they are dominant to that one. So what are our expectations? Of course, as you know, we've taken the assumption that black body is recessive, normal body is dominant. And then being eyeless is recessive and having eyes is dominant. So what do we expect when we cross the F1? When we cross the F1, we expect the F1 to be heterozygous. So they have the brown body with eyes, but they are heterozygous. And what are the expected ratios? 9 to 3 to 3 to 1. So when they carried out this experiment, this is exactly what they got. 5,610 wild type. These are observations they got when they crossed F1 with another F1. So it means that these flies we're observing, they are actually the F2 generation. The question is, based on these results that we are seeing here, do we think that they align with Mendel's laws of inheritance, or they do not, meaning there must be something causing a deviation from Mendel? Because Mendel's prediction would put it at 9.33 to 1. But if we realize that these ratios are not obeying that 9.33 to 1, then we would suspect that there must be a specific cause. So how do we know that these observations, they align with that expectation or they don't align? We perform a chi-square test. So we draw a table like this, where we have the phenotype, observations, expectations, then observation minus expected is squared, divided by expectation. So the observed phenotypes, of course, they are these ones from the experiment, the 510, 1881, 1896, 622. So then we get their sum. So that is 5610 plus 1881 plus 1896 plus 622. So the total is 10,009. Okay. Then what would we expect? A ratio of 9 to 3 to 3 to 1. The 9 is always the dominant trait. Then the 3 to 3, this is the mixed phenotypes. So it could be normal body but without eyes, that is eyeless. So it is kind of mixing the genes. What about this one? This is a black body, but now it has eyes. What about this one? This is the recessive phenotype. So recessive in this situation is black body, eyeless. That's the recessive phenotype. So how do we calculate the expected phenotype for wild type? We just say 9 divided by the total ratio, which is 9 plus 3 to 1, which is 16, times the total number of offspring we had, which is 10,009. So that's what we do. 9 divided by 16 times 10,009. Then we get 5630. So then the next column is observation minus expected squared. Observation for the first column, observed, is 5610 minus expected 5630. Then I square. So what do I get there? And then the next one is 1881 minus 1877 squared. So 4 squared is 16. Then we do the last column, which is observation minus expected squared divided by expected. For the first column over there, we already have observation minus expected squared, which is 400. Therefore, we'll just do 400 divided by expected. Expected in that same column is 5630. So we do 400 divided by 5630. Then we get 0.0710. And then we do the same for all the others downwards. So this is the calculated chi-square value. Remember, the degrees of freedom are the number of phenotypes minus 1, or the number of options. So we have 1, 2, 3, 4. So we have 4 phenotypes. So we're going to say 4 minus 1, and that is 3. Those are the degrees of freedom. Then the probability level that we always use is 0.05. Then we go on the table for the probability values. We look for that a chi-square value, and we see whether it is bigger or less than this number over there. So when we look here on the table, the degrees of freedom are 3, so we're going to look over there. Then the probability level 0.05, so we need that number. This number over here, the 7.82, it is the critical value. So if your chi-square value is less than the critical value, you fail to reject the null hypothesis. So what was the null hypothesis? Null hypothesis is that there is no significant difference between the observed phenotypic frequencies and the expected phenotypic frequencies. Why did we fail to reject? Because the chi-square value is less than the critical value at 0.05 significance level and 3 degrees of freedom. Good time, bye.